The following video will be an introduction to the scientific method, as well as information as to what makes a question a good one. So there are a number of steps in the scientific method, which will be covered through a series of videos. So the scientific method, so what is it? So it is a way to find answers to questions in which your answer is most likely to be correct, your educated guess. You want a method that is repeatable by others, and a way in which you minimize your chances of making a mistake. So this is what will help your answer most likely be correct. So in the scientific method, the first step is you need a question or a general purpose. So, with that question, what does the scientist want to learn more about? What do you want to learn more about? So that is generally what will guide the purpose. The next step then, once you have that question, is to do a little bit of research. And that research is basically going to be gathering information. Once you've gathered some information and maybe refined your question a little bit, and just note, like, the arrows are all pointing in one direction, but the arrows could easily go the other way as well. It's a very dynamic process. So one step, may lead into the next, but you may have to go back to the previous step to refine what you have. After you've done some research and you have a question, you can then work on generating a hypothesis. That hypothesis is an educated guess or an answer to your question. Now, once you have that hypothesis, you are going to design an experiment or come up with a procedure that will help you answer that hypothesis or determine whether your hypothesis is correct or incorrect. And so this is where you come up with that experiment. So this is a written and carefully followed step-by-step experiment that will be designed to test the hypothesis. Once you have your experiment designed and created, you're going to conduct that experiment and collect data. So this leads into results. So those results can take the form of data and observations. So the data, in this case, is the information collected during the experiment. And with those observations, those are written descriptions of what was noticed during the experiment. So if there were color changes or sparks or bubbles, these are things that you would want to write down. Now, the information that is collected can take on two forms. So that data that is collected would be generally considered quantitative information. And quantitative information are measurements and numerical information. So if you're growing a plant, let's say, and you want to know how sunlight affects the growth of a plant, you would measure the height of the plant each day or each week, and that would be like a quantitative measurement. Now, with these written descriptions of what you have observed, this takes the form of qualitative information. And these are things that are observed using these senses. So, you observe that the plant is green, for example. And, maybe in the plant that is growing in conditions with low sunlight, it turns a pale yellow. These would, that would be like qualitative information. Now, to kind of remember the difference between quantitative and qualitative, I always look at the fact that quantitative has an N in it, and that N stands for numbers or numerical information, so you're always gathering numbers with quantitative information. Once you have that quantitative information and qualitative information, you would do an analysis of that data that would allow you to make your conclusions. And so in the conclusion, you're basically getting at, um, you're basically trying to determine, was your hypothesis correct or incorrect? So that original answer that you came up with, that educated yes to what your question was going to be, you would use the data then to determine if that hypothesis was correct or incorrect. One important thing to note with a conclusion and your hypothesis is that you're never trying to prove a hypothesis, or you're not trying to prove that it's correct, or prove or show that it is true. All you're doing is testing your hypothesis with a scientific experiment. Now, in the first part, we'll look at the question or the purpose and what makes a good question. So what is a good question? So a good scientific question is one that can have an answer. So we'll consider these two scenarios here, and we'll put a check mark beside what is a good question. We'll determine which is the better question. So why is there air, or what is the air made of? So if we're looking at a question that can have an answer, why is there air? We really can't come up with a concrete answer for that. We could philosophize about why there is air, but it's not something that we can get an answer to. What is air made of? We can sample the particles of air and actually determine what the air is composed of and what percentage molecules make up that air. And so, what is air made of would be a good question that satisfies this particular criteria. A good question can be tested by some observation or measurement that you can do. So where did the universe come from? Or how fast does a football fly through the air when I throw it? Well, you can, observe the universe, but you can't really measure it. So trying to come up with an answer to this question is not entirely possible or feasible. How fast does a football fly through the air when I throw it? You can measure how far that football is thrown, and the time it takes to reach a particular distance, and you can figure out speed from there. A good scientific question builds on what you already know. What chemicals are needed to make radishes grow? What is the source of genetic mutations in Drosophila melanogaster? So based on what you already know, chances are you might know what a horseradish is or radishes are, and you could build upon an experiment or that existing knowledge that you have in terms of what chemicals would help radishes grow. Whereas, what is the source of genetic mutations in or fruit flies? That might, be kind of beyond the realm of expertise that you may have. A good scientific question can lead to other good questions. So what is the color of the sky? You answer that and, you're done, job done. What events or conditions cause the sky to be blue or orange or brown? So here, we've looked at the conditions that can cause it to be blue, but then we could also consider what would make the sky orange or brown or red or sometimes purple. So, we could lead, this particular question can lead to other interesting questions as well. A good question is specific and clearly worded. So why do leaves turn brown versus does the amount of water or sun a plant receive affect the color of the leaf? Here we have a very general question about why do leaves turn brown versus like this very kind of specific question here. A good question is linked to the topic that is being researched. If you want to learn about gravity, which of the following would be a good question? What materials are best at keeping astronauts warm in space? How do astronauts' bodies change when they are in a zero gravity environment? The question with the word gravity in it links to what you want to learn about, which is gravity. A good question could have many answers. It is not a simple yes or no. So do plants grow in the dark? Well, I think we know the answer is no. What light conditions are best for plants to grow? So here, we have the possibility of many answers that would lead to an investigation to allow us to come up with an answer. A good question is one that you already don't know the answer. So how is a planet's motion influenced by objects around it versus when is my birthday? Yeah. Ideally, you know when your birthday is, but you probably may not know how planets' motions are influenced by objects around it. So in the following, we'll go through these at a different time, but consider which of the following do you think are good questions, and then be prepared to explain your decision. So use the rationale that we have just gone through to explain whether it is a good question or not. And so that is the end of this video for an introduction to the scientific method, as well as what makes a good question.